Hi everyone. So today we're going to work on composition of two functions, or maybe some more. We'll start with two. So it is an operation like adding, subtracting, multiplying, dividing, but it's something that we've never seen before. So there's a very kind of a weird definition. So we're going to kind of take it a little slow and see where this takes us. It says the composition, so we're going to be able to find the composition of two or more functions today. Composition function g with function f is written as g, little circle f, and we read that as g composed of f, or with f. And is defined as g composed of f is equal to g composed of f. Notice that there's two ways to write this, one with the little circle. Sometimes you're going to hear me say GOF, because it looks like GOF. And G, and then notice that it's kind of a nesting thing, okay? So basically this is saying take F and put it inside G, all right? The domain of G composed of F consists of all the X values in the domain for F, which F of X is in the domain of G. We're not going to worry about so much about domain today. We're just going to focus on can we do the composition. So here's what we're going to do. G composed of F is equal to G composed of the nesting. Okay, so both are acceptable notations of the composition. So we're going to evaluate f of x first because that's the innermost function. So here we're working from the inside out. Okay, think of those little nesting dolls, the Ukrainian nesting dolls. They were on Toy Story. You know, the mom opens up and then there's another one on the inside and then another one on the inside. Kind of along that lines where we're going to work, except we're going to go backwards. We're going to start with the inside and go out. Okay, and we're going to evaluate the f of x first and then use that answer to put it in to g of x. So if that's what we're going to do if it's numbers, and if it's the expression when there's no numbers, we're going to do the same thing. We're going to start with f of x and we're going to go into g of x. Okay, it's not commutative. It doesn't go both ways. Like addition and multiplication, the order in which you do things doesn't matter. You're still going to get 3 plus 4 is the same as 4 plus 3. That doesn't happen here. So you have to be very specific of who goes where. That's why we always start with the innermost function. Okay? All right, so here's our two functions. X minus 5 and x squared. Okay? So what is f composed of g? So that means that this is another way to write this. F composed of g of x is the same as f composed of g of x. Okay, these are equivalent notations. So this means that g is the innermost function. So we're going to take g and we're going to come over here to f. We're going to replace the x with it. So I'm going to take out the x and replace it with x squared. I'm going to take out the letter and replace it with x squared. Okay, so this means I'm going to take and I get x squared minus 5 because I took out the x in x minus 5 and replaced it with x squared. That's it, okay? Now if we need to clean up, do some math, eventually we're going to do that. All right, let's go the other way. So this says g composed of f of x. Okay, so this means I'm starting with f of x. And I'm going to go to g because f of x is the innermost one, and I'm going to go to g. So I'm going to take this guy, and I'm going to come over here, and I'm going to replace the letter with x minus 5. So that means x minus 5 quantity squared. And then we're going to do the math, write it twice and multiply. We're going to get x squared minus 10x plus 25. Okay. All right, so what is f composed of g of negative 3? You have two ways you can do this. We can take our f composed of g, which was x squared minus 5, and replace x with 3. Negative 3, sorry. So that's my minus 5. or 4. Or you can take g of negative 3, which is going to be negative 3 squared, which is 9, and then find f of 9, and go 9 minus 5, which is 4. So depending on what you want to do. Now, since we already had the expression, probably the first one. If I didn't have the expression, I would probably do the second method. Okay. Way different thinking than what we're used to doing. So let's try another one. And I think I wrote the same thing twice. I did. Why did I do that? No, that's okay. I just have same expressions, different evaluations. Okay. So let's try the next one. Okay, so f is 3x plus 2, and g is x squared plus 1. So the first thing is saying, what is f composed of g? Okay, so remember, we can write this as f composed of g of x, which means that g of x is what I'm going to start, and then I'm going to come over here, and I'm going to take out the letter x and replace it with that. So this becomes 3 times x squared plus 1 plus 2. So 3x squared plus 3 plus 2, or 3x squared plus 5. Okay, so one of the things that I like about this, or it reminds me of, if you are in music, okay, band, chorus, the musical, whatever, or you listen to music, when the great composers, whether it be classical like Beethoven and those guys, or the newer ones, when they compose rap songs or the heavy metal things or anything like that, you're creating something. So the idea of composition is that you're composing something new from something else. Like you're creating, and you take things and you make something new, so you compose it. So the idea of composition in math is that you're creating or composing, and you're taking two functions and you're creating something new from that. Well, that's just my thoughts. All right, so g composed of f, remember that means g composed of f of x. So we're going to start with f, because that's the innermost guy, and I like to think of it as the one that's closest to the x. So let's get rid of what we did last time. So we're going to start with f, and then we're going to come over here and we're going to take out the letter and replace it with what it is. So we're going to get 3x plus 2 quantity squared plus 1. So I'm going to multiply that. So that's 9x squared plus 12x plus 4 plus 1, or 9x squared plus 12x plus 5. Okay. All right, so this says f composed of g of 2. So I can go to my f composed of g, which is the one right above it. Okay, so f composed of g of 2. And put 2 in for x. Okay, so that's 3 times 4 plus 5. So it's 12 plus 5, or 17. Or I can find g of 2. So that's x squared plus 1. So that's 2 squared plus 1, or 5. And then find f of 5. And I can get, what is it, 3 times 5 plus 5. That's not right. 3x plus 2. I don't know why I said 5. So that's going to be 15 plus 2, or 17. You get the same answer, it's just which one's going to make more sense to you. All right, let's try something, again, a little different here. We have f composed of f. So something composed upon itself. So f is closest, so I'm going to go to f. And then I'm going to go to f again. So I'm going to take out this x and replace it with 3x plus 2. So 3 times 3x plus 2 plus 2. So 9x plus 4, no, sorry, plus 6. Fat fingers. Plus 2, or 9x plus 8. All right. Okay, so these were the same two functions we did in our example. Your choice, okay? I'm going to do them if you want to pause and then see what happens, okay? So I'm going to do it this way because I'm not going to find the composition, so. So my answer to that one is 64. So here I'm going to find g of negative 3. And then f of 9. Okay, notice that it's the same number, two different compositions, completely different answers. And that's the point of it's not commutative. Okay, g composed of f. So x minus 5. I think we did this. And f composed of f of 2a. So I'm going to find f of 2a. And then there we go. All right. Okay, so hopefully that helps. I do have a lot of resources on composition, so I'm going to put them all in our folder so that you have access to like a whole bunch of worksheets and funky videos and maybe quizzes or something, so that kind of helps with the whole concept. Sometimes it's visual, sometimes you can look at it in terms of a graph, and there's some really wild stuff that happens here. All right, so why do we care? Here we go. Okay, we're going to go shopping. We're going to buy a car. I have a CRV that's 15 years old, almost 16 years old. So it's got 118,000 miles on it. So it's getting time. So I might buy a RAV. I really like the new RAVs. Can't afford one. So I'm going to wait a couple years and then the RAV. I think I'm going to get a RAV. We'll see what happens. Something else could come out. I may like that better. But a car dealer offers a 15% discount for the list price, which we're going to call X, of any car in the lot. At the same time, the manufacturer offers a $1,000 rebate for each car purchase of a car. So this actually happens out there. My neighbor just bought a car. This was one of the things that happened. Do you get to take the discount or do you take the rebate, which is a better deal? So we're going to write a function f to represent the price after the discount. So f of x is equal to, okay, if you're 15% off, you're paying 85% of the price. Okay. Write of g of x to represent the price after a $1,000 rebate. So price minus 1,000. Okay, suppose the list price of the car is $18,000. Use the composition function to find the price of the car if it is discount is applied before the rebate. So we're going to do f of 18,000, and then we're going to do g of that because we're going to find the price after the rebate, and then we're going to take the rebate. Now, I don't think my calculator is going to show up here. Okay, so I'm going to do 0.85 times 18,000. Okay, crap. Delete. Just putting things things in. Okay, so F of 18,000 is 15,300. Okay, and then we're going to find G of 15,300. So we're going to subtract $1,000. So if we take the discount before the rebate, we're going to pay $14,300. Okay. Now, suppose the list price of the car is $18,000. Use composition to find the price of the car if the discount is applied after the rebate. So in other words, we're going to find F composed of G of 18,000. So we're going to take the rebate first, and then we're going to do our discount. Discount applied after. Okay, so we're going to find G of 18,000. So that's going to be 18,000 minus 1,000. That's going to give us $17,000. So then we're going to find F of 17,000. So that's going to be 0.85 of 17. $14,450. Okay, so we can see we're going to want to take the discount first and then apply the manufacturer's rebate. All right, which will the dealer want? Which one would the dealer want? Not you, but which one would the dealer? The dealer is going to want discount, then rebate. Because he's going to make an extra $150 if he does that. All right, guys. Let me know if you have any questions. Please stay safe out there, and I'll talk to you again real soon.